I don't hate you, it doesn't mean that I love you, right? But when the null hypothesis is rejected, when I say this model is not true, I do accept the alternative hypothesis. I say that I accept the alternative hypothesis in favor of the null hypothesis given the data that I found. So yeah, the difference is we don't accept the null hypothesis, but we can accept the alternative hypothesis. So let's try that out. I do want to say that the examples that I have today are, I didn't make them, but I think they're really funny. So credits go to Richie. I don't know who that is, but he made these. Jermaine just saw Dune and is now convinced that Timothée Chalamet is the next big thing. He conducts an experiment with two conditions, one where people watch a Timothée Chalamet film and the other one where they do not. After he measures the proportion of people that says their depression has been cured. Germain hypothesizes that there will be a difference between conditions, but he does not specify what sort of difference this will be. Which hypotheses describe Germain's study? You can put it in the chat when you know. Ooh, you guys are fast. Yes, it is C. He doesn't specify a difference. He just say that, it's just going to be different then. And so as you see, the null hypothesis is the same for all these options. So no matter what you say about the alternative hypothesis, the null hypothesis is always going to be the same because you're always talking about the same population. And then the alternative hypothesis is either going to be bigger than this value, smaller than this value, or different from this value. If Germain decides that the null hypothesis can be rejected at a significance level of 0.05, then if there really is a difference between conditions, is the p-value less than or equal to 0.05? Is it less than or equal to 0.95? Or is the probability that the alternative hypothesis is true 0.95? Yes, it's gonna be A. So just to, why not C? So to reiterate, if the p-value is less than or equal to my significance level, then I'm saying that the p-value tells me the probability of finding this value given that my null hypothesis is true, right? So if this p-value, if this probability becomes smaller than this cutoff point, then I'm saying that it's so unlikely that I find this distribution, that I find this value in my distribution, that they must be significantly different from each other, and not due to just random sampling variability, right? Because these are the two options I have. My values are always going to be somewhat different, and they are going to have different probabilities of being this different from each other. But most of those differences are going to be because of random sampling variability. And I have my cutoff point of 0.05, and I'm saying that if the probability reaches 0.05 or smaller than that, then I'm going to say that it's no longer due to random variability, but that they are actually significantly different from each other. The reason that it's the probability that the alternative hypothesis is true is 95%. This is not true because if there's a difference of 0.06, it's not significant at all. No, it's going to be unlikely, and that's why there's a lot of like discussion about this cutoff point. It was never meant to be like a full cutoff point, but if it's higher than 0.05, then it's not significant. Even if it's 0.051, then it's not significant at that point. So the probability This has to do with the direction of inference. I don't fully know how I can quickly explain this, actually. Maybe I should have taken this out. But the probability that the null hypothesis is true is not the same as the probability that the alternative hypothesis is true. Or the probability that the null hypothesis is false is not the same as the probability that the alternative hypothesis is true. You'll find this in the summary that we sent you as well. It has a bit of a better explanation than I can give you right now. I'm really sorry. But yeah, I think that in this sense, it's just really important to understand that a p-value tells you whether or not there is a significant difference between the conditions that you have, and it doesn't say anything about the probability that anything else is true. Yeah, let's take a 10-minute break.